This is a video from section 3.11. We're going to look at derivatives of hyperbolic functions. So we're going to start with number 1. Suppose we want the derivative of the hyperbolic sine of x. Now, I would prefer to look at the hyperbolic sine of x in terms of its exponential equivalent. So, in other words, I'm going to write this as the derivative of e to the x minus e to the negative x divided by 2. Now, if I look at this, the 2 doesn't go anywhere. That's just going to stay. If I look at the derivative of e to the x, the answer is e to the x. The derivative of e to the negative x is negative e to the negative x by using the chain rule. But if you notice, this is e to the x plus e to the negative x over 2. And that's the same as hyperbolic cosine of x. So we can say that the derivative of hyperbolic sine of x is the same as hyperbolic cosine of x, or is equal to hyperbolic cosine of x. Number 2. Suppose I want the derivative of hyperbolic cosine of x, but that's the same as the derivative of e to the x plus e to the negative x divided by 2. Now, the denominator, again, doesn't go anywhere. Now, if I want the derivative of e to the x, that's e to the x. And then the derivative of e to the negative x is negative e to the negative x by using the chain rule, right? And so we can write this as e to the x minus e to the negative x divided by 2. And that's the same as hyperbolic sine of x. Therefore, the derivative of hyperbolic cosine of x is the same as hyperbolic sine of x. Let's take a look at number 3. Suppose we want the derivative of hyperbolic tangent x. But remember that this is the same as the derivative of hyperbolic sine of x divided by the hyperbolic cosine of x. And so what I'm going to do here is I'm going to apply the quotient rule. So I'm going to write the bottom, which is hyperbolic cosine x, and then I'm going to take the derivative of the top. Well, the derivative of the top, the derivative of that hyperbolic sine of x is hyperbolic cosine x. So I'm going to write hyperbolic cosine x minus the top, hyperbolic sine x. The derivative of the bottom, the derivative of hyperbolic cosine x, is hyperbolic sine x. And then I'm going to divide by hyperbolic cosine x to the second power. And so this is hyperbolic cosine squared x minus hyperbolic sine squared x divided by hyperbolic cosine squared x. But if you remember from the last video, hyperbolic cosine squared x minus hyperbolic sine squared x, that's the same as 1. And so this is 1 over hyperbolic cosine squared x. but that's equal to hyperbolic secant squared x. So therefore, the derivative of hyperbolic tangent x is the same as hyperbolic secant squared x. So you notice we're writing everything in terms of hyperbolic sine x or hyperbolic cosine x. Let's take a look at number 4. Suppose I want the derivative of, so we have here the derivative of hyperbolic cosecant x. But I'm going to write this as the derivative of 1 over hyperbolic sine of x. Okay? Now, what I'm going to do is I'm going to say that this is the derivative of hyperbolic sine of x to the negative 1 power. And then we apply the power rule combined with the chain rule, right? So this is negative 1 times hyperbolic sine of x to the negative 2 times the derivative of that hyperbolic sine of x, which is hyperbolic cosine x. And so if we don't mind, I'm going to write this as negative hyperbolic cosine x divided by hyperbolic sine of x to the second power. And so when I go to simplify this, we can say, therefore, the derivative with respect to x of hyperbolic cosecant x is the same as, so if I take hyperbolic cosine x over hyperbolic sine x, I get hyperbolic cotangent x. So this is negative hyperbolic cotangent x times hyperbolic cosecant x. Now, where did I get that? Let's make sure we understand that. So I'm going to take this and rewrite it just a little bit. So negative hyperbolic cosine x divided by hyperbolic sine squared x is negative hyperbolic cosine x times 1 divided by hyperbolic sine x times hyperbolic sine x, okay? But if we look at this piece, that's equivalent to hyperbolic cotangent x. And remember, there's still a negative sign. So let's try that again. So this is negative hyperbolic cotangent x, and I'm going to take that and I'm going to multiply by, now 1 over hyperbolic sine x is hyperbolic cosecant x. So let's write that down. And that's where we get this derivative from. Let's take a look at number 5. So if I want the derivative with respect to x of hyperbolic secant x, this is the derivative with respect to x of 1 over hyperbolic cosine x, which is the derivative with respect to x of hyperbolic cosine x to the negative 1. And we're basically doing the same thing. It's the same idea as number 4. So this is negative 1 times hyperbolic cosine x to the negative 2 times hyperbolic sine of x. Now, what I'm going to do is I'm going to write it this way. So I'm going to say negative hyperbolic sine of x. I don't want negative exponents. And so I'm going to take negative hyperbolic sine x. If you don't mind, I'm going to multiply it times 1. And I'm going to divide by hyperbolic cosine x times hyperbolic cosine x. And so if we remember, hyperbolic sine of x divided by hyperbolic cosine x is equal to hyperbolic tangent x. So this is negative hyperbolic tangent x times hyperbolic secant x. Remember that 1 over hyperbolic cosine x is hyperbolic secant x. And so therefore, the derivative of hyperbolic secant x is negative. I'll just say hyperbolic tangent x times hyperbolic secant x. And then the very last one is number 6. Suppose we want the derivative of hyperbolic cotangent x. But that's the derivative of hyperbolic cosine x divided by hyperbolic sine x. And so this is a little quotient rule. So I'm going to write down the bottom function, which is hyperbolic sine x. I'm going to take the derivative of the numerator, right, which is hyperbolic sine x. Subtract the top times the derivative of the bottom, which is cos x, right? In other words, hyperbolic cosine x. And then I'm going to divide by hyperbolic sine of x to the second power. So this is just basically quotient rule. Okay? And so this is hyperbolic sine of x squared minus hyperbolic cosine x squared divided by hyperbolic sine of x squared. So what I'm going to do is I'm going to factor out a negative out of the numerator. So I'm going to take a negative 1 out, and I get hyperbolic cosine x squared minus hyperbolic sine of x squared, right? That's on top. And on the bottom, we get hyperbolic sine of x squared. But if you guys look inside those brackets in the numerator, that's equivalent to 1. And so this reduces to negative 1 over hyperbolic sine of x squared. But this is equal to negative hyperbolic cosecant squared x. So, therefore, the derivative of hyperbolic cotangent x is negative hyperbolic cosecant squared x. So, in other words, so what we ended up doing is we figured out the derivative of hyperbolic sine of x and hyperbolic cosine of x. And then from there, we rewrote the other 4 hyperbolic trigonometric functions in terms of the hyperbolic sine or the hyperbolic cosine, or both. And then we were able to figure out the rest of the derivatives. Let's look at some examples of taking derivatives, applying this idea, okay? So if we have f of x equals hyperbolic sine of x squared, and I want to take the derivative. So this is a great application of the chain rule because the outside function is the hyperbolic sine. The derivative of the hyperbolic sine is the hyperbolic cosine. So I'm going to write the hyperbolic cosine of the inside function, which is x squared, but I'm going to multiply by the derivative of that inside function. That inside function happens to be x squared, so we're going to take the derivative of x squared. But the derivative of x squared is 2x. So I'm going to write that down. And so if we write this in a little different order, we can say that this is equal to 2x times hyperbolic cosine of x squared. And that's a classic use of the chain rule. Now, suppose I give you this one. Suppose I had f of x is e to the x times hyperbolic cosine x. So this is the product rule now. So I'm going to take the derivative of e to the x, which is e to the x, and I'm going to multiply by cosh x. So we leave that alone. Plus, and now I'm going to write down e to the x, and I'm going to multiply by the derivative of cosh x, or in other words, the derivative of hyperbolic cosine x, which is hyperbolic sine of x. Okay? And we can factor out an e to the x, and we get hyperbolic cosine x plus hyperbolic sine of x. Now, I don't know how far the instructor wants you to simplify, but I do want to show you something. Now, if you remember, hyperbolic cosine of x is e to the x plus e to the negative x divided by 2. So I want to get you guys at least thinking about this, okay? Now, hyperbolic sine of x is e to the x minus e to the negative x divided by 2. But we could add that up, right? And so f prime of x is e to the x times e to the x plus e to the negative x plus e to the x minus e to the negative x, and this is divided by 2. But the e to the negative x's cancel, and we get e to the x times 2e to the x divided by 2. But if you notice, the 2's cancel, and e to the x times e to the x is e to the 2x. And so therefore, f prime of x is e to the 2x. This is ideal. This is completely simplified. This is okay, but it would be ideal for you to be able to completely simplify this. Okay? And that's how you do example 2. Let's go ahead and take a look at example 3. I want to at least do a few more examples for this video. So if we take a look at example 3, we have f of x is natural log of hyperbolic sine of x. So f prime of x is 1 over hyperbolic sine x times the derivative of the inside function, which is hyperbolic cosine x. And so this is equal to hyperbolic cotangent x. That's it. You're done. And so therefore, f prime of x is hyperbolic cotangent x. Let's take a look at example 4. Suppose we had, this one's good. Suppose we had y equals hyperbolic secant of hyperbolic tangent x. And we want to take the derivative. So we want to know what y prime is. Now, let's go back. We need to know the derivative of the hyperbolic secant function. Now, it's sort of similar to what we did in trig, but it is a little bit different, okay? So if you notice, the derivative of the hyperbolic secant function is negative hyperbolic tangent hyperbolic secant of x. So if we go back to here, so we're going to take negative hyperbolic tangent of the inside function, which is hyperbolic tangent x times hyperbolic secant of hyperbolic tangent x times the derivative of the inside function. So let's get ourselves a little bit of room here, because we're going to need room for this. So I'll rewrite, don't worry, I will rewrite this. So we're going to take y prime. So we're going to take negative hyperbolic tangent of hyperbolic tangent x times hyperbolic secant of hyperbolic tangent x times the derivative of hyperbolic tangent x. So let's go back. So we need the derivative of hyperbolic tangent x. Well, it looks like it's hyperbolic secant squared x. So we're going to write hyperbolic secant squared x. So I'm going to write negative hyperbolic secant squared x times hyperbolic tangent of hyperbolic tangent x. Oh, not tangent. There should be an h in there. Times hyperbolic secant of hyperbolic tangent x. And we'll conclude this video for section 3.11. This is problems. Well, we took the derivative of the 6 hyperbolic trig functions plus 4 additional examples. Thank you.